All right, well, welcome everyone. My name is Jamie Sunkel, and I'm a space education specialist here at the Space Foundation in Colorado Springs. And we are here celebrating 2014 World Space Week. So I know that you guys have all been doing lots of fun stuff in your classrooms, and that you're very excited about our virtual audience with an astronaut talk. So I'd like to go ahead and introduce our astronaut. This is Dr. Leroy Chiao. He was on 4 space shuttle missions, and he spent 6 months on the ISS, and he's going to talk to you about his time in space. He's also going to talk to you a little bit about the future of space exploration, and then we're going to have some time to answer all of those great questions that your teachers and principals emailed me. So let's get started. Dr. Chiao, you ready?
Ready.
All right.
All right. Thank you, Jamie, and hello, everyone. Welcome to Springs virtually for World Space Week. My name is Leroy Chiao. I'm an astronaut. I'm also the special advisor for human spaceflight for the Space Foundation, and it's a pleasure to be talking to you. I guess it's morning for you. Anyway, I can't remember a time when I wasn't interested in airplanes and rockets. I built a lot of models when I was a kid and read a lot of books, but it really was the Apollo moon program that made me start thinking about wanting to become an astronaut myself. I was 8 years old when Apollo 11 landed on the moon, but I remember like it was yesterday. And I remember being amazed that there were actually people on the moon right as I was watching them on TV. And so that really made a big impression on me, and even as a kid, I knew I had to make a plan. I knew I had to do well in school so I could go to university, and so, which would give me a chance to become an astronaut. So I studied engineering. I did well in school. I studied chemical engineering, and I got 3 degrees in chemical engineering, and I was working at the Lawrence Livermore National Laboratory in California when I applied to NASA. I put an application in, and then 7 months later, I was called by NASA, kind of a big surprise, just called me out of the blue to come down to Houston to interview to become an astronaut. So that in itself was very exciting. And then 4 months after that, I got the big call inviting me to join NASA in that group of astronauts. And so, as you can imagine, that was a very exciting time. I packed up my things, I moved from California down to Houston, and that's where I've lived now for 24 years. I was actually at NASA for 15 years, and during that 15 years, I had the fortune to fly 4 times into space. My first 3 missions were aboard space shuttles, and on my 4th mission, I trained with the Russians, and I flew to the International Space Station. My first mission was aboard Space Shuttle Columbia. It was a science mission, so we had what was called a Space Lab module in the back of the payload bay, and we conducted scientific experiments for 2 weeks. And after that 2-week mission, we had actually accomplished over 80 different experiments. On my 2nd mission aboard Space Shuttle Endeavour, it was the first chance I had to put the spacesuit on and go outside and lead my first 2 spacewalks. And what we were doing, we were testing tools and construction techniques of how we were going to build the International Space Station. So a few years later, on my 3rd mission aboard Space Shuttle Discovery, I got to put that into practice. We went up to the space station. We brought 2 pieces of the space station with us aboard the space shuttle. We used the robotic arm to position those pieces, and then over 4 spacewalks and 2 teams, we went out and used tools to bolt those pieces down and connect the electrical connectors and bring them to life. After that mission landed, after Discovery landed, somehow 10 years had gone by. I had flown 3 space shuttle missions, and that's when the chief asked me to join the Expedition Corps. And this is something I hadn't thought much about before because I was concentrating on how we were going to build the space station and short shuttle missions. Now I was being asked to train to live and work aboard the station on what turned out to be a 6.5-month flight. And so the first thing I had to do was decide that I wanted to live in space for 6.5 months. And just imagine that. That's 2/3 of a school year. That's most of a school year living in space in pretty small area, just small modules. And in addition to that, the bigger commitment was training. I trained for 3.5 years, which is almost enough time to get another college degree. I had to learn Russian. I had to learn the Russian language because I was going to be working, spending half of my time in Russia. And I was traveling back and forth, 1 month in Star City outside of Moscow, 1 month in Houston. Now, the Russian cosmonauts had to do the same thing. They had to make the same commitment. They had to learn English and spend half of their time in Houston. But in the end of the day, it was a very worthwhile, very worth the investment. I launched from the Baikonur Cosmodrome aboard a Russian Soyuz spacecraft. We launched to the International Space Station, where I served as commander for 6.5 months. We spent the time in orbit doing different experiments and also doing maintenance work. And then after landing in the Soyuz, I finished out the rest of that year writing the reports, doing the debriefs, and visiting and thanking the people who supported the mission on the ground. And then it was time to go do other things. And so since that time, I've been working in consulting. I've also do a little teaching at Rice University in Houston and also Baylor College of Medicine. And of course, I very much enjoyed working with the fine folks here in Space Foundation and opportunities to talk to people like you all around the world and talk to you about space. We're talking about a little bit about where we're going in space. As you know, if you've been following the news in the United States, we've kind of gone in a few different directions, but I can kind of give you an update now. We are still building the next generation spacecraft called Orion. As you know, the space shuttle was retired 3 years ago after we finished building the space station. So Orion is being built to go farther and deeper into space. We're building a new set of rockets called the Space Launch System, and one variation will take the Orion to low Earth orbit. The other variation will take other components of a spacecraft, a deep space spacecraft, that will go explore beyond low Earth orbit. You've probably heard of the Asteroid Redirect mission. NASA is now working towards robotically bringing a small asteroid into orbit around the Moon and Earth. And then Orion is planned to go fly some missions with that asteroid. So the point is, things are happening, and probably the most exciting part is that commercial companies are being assisted by NASA to develop the capabilities to take astronauts to and from the International Space Station. You've probably heard of SpaceX. You know that they've been very successful in bringing cargo to the station, and now they're working to bring astronauts to the station as well, along with the Boeing company, who's developing their own spacecraft. So I think the best use of the time now would be to open it up to the questions that you have given to your teachers and your principals and have been sent over here. And so Jamie's going to join me here, and we'll go through some of the questions that you students have.
And we have quite a few questions for you, Dr. Chiao.
Okay.
So the first set of questions are going to come from the Vikar Patel Memorial School in Pune. And these come from Vice Principal Mrs. Karan. And the first question her students had was, how do you manage yourself up there when everything is just floating? Did you face any problems with all that?
Yeah, so the weirdest part about the space environment is you are floating, and everything else is floating as well. And so you quickly get used to the idea that you have to use your fingertips to move everywhere, and that you have to use your feet to hold on to handrails or other things when you need to secure yourself. Now, the biggest thing is all the other objects are floating as well, so you've got to think through how you're going to do things. And that's why most things aboard the station or in space have a piece of Velcro on it, so you can stick it to a wall when you're not using it so it won't just float away, or you have to slip it behind an elastic bungee so that you can secure it. But then again, if somebody goes by and bumps into it, then they could be free and lost. So that is one of the most frustrating things about being in space, is losing things. You've got to be very careful not to lose critical items, because they could really set you back.
All right, so our next question, while on takeoff, G-forces act on your body.
Mm-hmm.
How does that feel?
It's actually not too bad, because if you're in an airplane and you're doing a loop, then the G-force is going this way, pulling the blood out of your head, and that's why sometimes you have people that black out, so that actually lose consciousness. But when you're in a spacecraft going up or coming down, the G-vector is going this way, and so really it just feels like someone's pushing on your chest, and it takes a little bit more effort to breathe, but it's not uncomfortable. And so the G-loading is not quite as bad as it makes out in the movies. It's not quite that bad.
All right. What inspired you to become an astronaut?
Well, as I said, you know, in my generation, we grew up in the Apollo era, and so it was the Apollo moon landings, especially the first one, that inspired a lot of us to dream about becoming astronauts.
So this student did quite a bit of research about you, and they said you're an engineer, astronaut, speaker, and engineering consultant. How is it possible for you to multitask so much, and which is your favorite career?
Well, actually, a lot of that was kind of in sequence. So I was an engineer first, working as a research engineer, and then I got accepted by NASA, became an astronaut. Now, after I left NASA, I did start doing several different things, and I kind of mentioned the things that I'm doing. But you do have to kind of manage your time. But I find it very interesting because instead of just going to one office and doing one thing all day and going home and then repeating the next day, I get to go do a lot of different things. I get to travel and work with a lot of nice people like the people here at Space Foundation.
All right, you ready for our next set of questions?
Sure.
This comes from Mrs. Swati's group of students. And the first question is, it's a planetary question for you. Okay.
Excellent. Okay. We got Mars back here.
Why is Mercury hot as well as cool equally?
Well, Mercury is hot and cold because the same side of Mercury faces the sun, right? It's not spinning like some of the other planets. And so the side that faces the sun is very hot because it's the closest planet to the sun, whereas the side that's facing deep space is much cooler because it doesn't get the heat directly from the sun.
You know, and I just noticed that the students from this school were very curious about the cosmos and the Mars mission in particular. So I think they might be trying to stump you a little bit with some
we'll
questions.
See.
Okay, so the next question is, how does the core of the Earth create the gravitational force?
Well, the core of the Earth, as you know, whoever asked this question, is molten. It's liquid, and it's mostly iron or metal ores. And so what you have is the Earth is spinning, and this molten core is also spinning, and that creates the magnetic field around the Earth. And that creates what we call the magnetosphere, which traps most of the radiation coming from the sun. And that's why life is possible here on the Earth. Mars, many years ago, millions of years ago, also had a molten core and also had a magnetosphere and also had a more substantial atmosphere. But then Mars slowly cooled down, the core started solidifying, and it lost its magnetic field and lost its magnetosphere. And so the radiation of the sun actually stripped away the atmosphere. That's why the atmosphere of Mars is so thin and why there's so much radiation that hits the surface of Mars as opposed to the Earth.
Okay, so this is another tough one. You ready?
I'm ready.
Okay, so why is the gravitational force at Bermuda Triangle very high?
Well, I don't think it really is very high. If you look at what's called the Bermuda Triangle, it's huge. I mean, it's really a large area, and so in this large area of ocean to say, well, we've lost all these ships and these airplanes, well, you could probably move that triangle almost to any major, area of the ocean where there's shipping lanes and where it's, air lanes, and you could probably also find a lot of things missing. So I myself am quite a skeptic of the Bermuda Triangle, and I've never heard of it having more gravity. I don't think that's true.
All right. And our last question from the Little Flower School of Loney is this. There is an asteroid belt between Mars and Jupiter. When these planets were formed, why didn't their gravity pull these asteroids?
Well, their orbital mechanics dictates the way that bodies will orbit each other or behave. And so when you have things like an asteroid belt, the reason that they're there is because there was some kind of a balance in the gravitation and the way the planets were orbiting that they did not get attracted towards one planet or another, but survive in their own belt. And so as you grow older, if you're interested in orbital mechanics, it can be quite a complex field, but they're solvable equations by numerical methods. You can actually study the effects of multi-body problems that are very complex, and you'll find the answers there. You'll see that mathematically it will work out that that's why these objects are where they are.
All right, are you ready for your fashion question?
Okay, fashion question.
Why do astronauts wear orange jumpsuits into space?
Orange suits were worn on the shuttle for a very important reason. It's because international orange is very visible. So in a rescue situation, if we had to bail out of the shuttle, we wore parachutes on our backs, and there were certain scenarios, especially during landing, if we got into a situation where we weren't going to be able to make it to a runway, there was actually a procedure to jump out of the space shuttle and use your parachute. And so when we would land either in the water or maybe on land in a wooded area, having a very bright orange suit would make you much more visible to the rescue forces.
All right. When you were in space and you were looking back on Earth, did you feel smaller or larger? And how did you deal with acclimating or the transformative experience of going from space
Mm-hmm.
to living back down on Earth?
Okay, well, when you look back at Earth, I mean, looking at the Earth from low Earth orbit is the best part of being up there. The colors are very bright, and it's really, the Earth is beautiful in different ways all over the place. So looking at the Earth, did it make me feel larger or smaller? I guess it made me feel much more appreciative of the Earth, of how big the Earth is. So in a way, I guess it made me feel a little smaller, but it was filled me full of a kind of wonderment and awe of, you know, what a beautiful planet we have. As far as reacclimating, you're right, it does take quite a bit to get used to gravity again. Even though you've been exercising in space, your balance is totally messed up. When you come back, you're dizzy, you can't walk straight, and it takes you at least several days, probably a few weeks before you kind of start feeling like you're back to normal.
If space has no oxygen, then how does rocket fuel burn?
Space doesn't have oxygen. Well, it has, you know, some molecules here and there, but it doesn't have enough certainly to sustain combustion like we have here on the Earth. So the way rocket engines work in space, you have to bring your oxidizer or your oxygen. So sometimes that might be liquid oxygen, or it might be another chemical compound with a lot of oxygen in it, like nitrogen tetroxide.
All right, this is a tough one.
Okay,
You ready?
I'm ready.
Okay. A person who travels in space becomes older slowly as compared to a normal person.
Mm-hmm.
Is this true?
Well, that is true, technically speaking, and it's Newton's special law. I mean, Einstein's special law of, or law of theory of special relativity. That as you approach the speed of light, there's something called time dilation, where time for that person from a different reference frame appears to slow down. It does slow down, and so what happens in space, though, we're traveling nowhere near the speed of light. These relativistic effects only happen when you start approaching, say, 90% the speed of light. And so speed of light is about 186,000 miles per second. And in low Earth orbit, we're traveling fast, but not nearly that fast. We're traveling at about 5 miles every second.
All right, we're going to switch schools.
Okay.
And these questions are from our teacher liaisons in Vidya Valley.
Okay.
And you've met them.
Oh, yes.
You remember
Yep.
Vandana and
Right. Yes.
Nalini? So the first question is there sound in space? If yes, then can we hear it clearly? And then how do you communicate with other crew members on board?
Well, there is no sound in space. In order for sound to travel, you need a medium like air or water for it to travel through. So in the vacuum of space, sound does not propagate. So there is sound, however, inside of your spacesuit because you do have oxygen, you know, an atmosphere, if you will, and there is sound inside the spacecraft because, again, you have an atmosphere or air. So strictly speaking, in space, there is no sound. We communicate with each other when we're inside the spacecraft just by talking like you would in a room or to another person somewhere. Or if we're talking between astronauts who are spacewalking or another spacecraft, we use radios, just the same way we use radios to talk from the spacecraft down to the ground.
Were there any dangerous situations on the ISS?
Well, you know, space is an unforgiving environment, and so there are dangerous situations in space. We try to avoid them as much as possible. We actually had an emergency when we were coming in to dock to the space station. The automatic pilot had a malfunction, and it started speeding us up and turning us away from the station. And so we had to take manual control and exercise our emergency procedures and manually dock the spacecraft. So that was an example of a dangerous situation in space.
All right, you have another student that has done some research
Okay.
about you. I have read that you have received a Bachelor of Science degree from the University of California, a master's degree, and a doctorate in chemical engineering. So what fascinated you to become an astronaut?
You know, as I mentioned before, I was always dreaming about being an astronaut since the Apollo moon landings. I was also interested in technical things, which is what made me pursue engineering. And I was having a fulfilling career as a research engineer when I applied to NASA. You know, and I was hoping I would be accepted, but then I knew if I didn't get accepted, I would continue to try. But in the meantime, I was also enjoying my research career. And so, you know, the fact that it did work out was good luck for me, and really enjoyed it.
Okay.
Okay.
Who inspired you to become an astronaut?
Well, it was the first guys on the moon. It'd be Neil Armstrong and Buzz Aldrin and Michael Collins as well in the command module of Apollo 11. In fact, all of the early astronauts were my heroes.
All right, so we're coming to an end.
Okay.
We're at our very last question for you. And this one, I have heard that it takes at least 180 days to reach Mars. So do you believe in human settlement on Mars, and would you like to be a member of that settlement?
Right. When we talk about transits to Mars, we typically talk about 6-month transit times when the planets are aligned. So on average, we talk about 6 months for one way there and 6 months back. But when the planets are misaligned, it can be quite a bit longer, right? And so as far as settling on Mars, we talked a little bit earlier about the magnetosphere and the lack of a magnetosphere on Mars and the lack of an atmosphere on Mars. And so settling on Mars would be very difficult because we don't even have the basics like oxygen. So we'd have to bring the oxygen with us. There is subsurface water. We could, figure out a way to get that water out of underground, and if we could have a power source there, we could make oxygen. In principle, we could use electrolysis to split the water molecules and take the oxygen for breathing. But these scenarios are very much theoretical. In other words, we know in principle they can be done. Putting it in practice is something else. So, in order for you to settle on Mars, you'd have to build habitats, you have to land habitats there, you'd have to land power supplies, you'd have to land tanks of oxygen or oxygen generating capability, food, water, you'd have to have a constant supply of these things coming from the Earth. And if those supplies ever stopped coming before you had the ability to get the water out yourself, you're going to be out of luck. And so would I want to be a settler on Mars? Plus, you're taking a lot more radiation, not having a magnetosphere. Frankly, I probably would not be someone who would want to colonize Mars. I would like to see Mars. I would not mind flying to Mars under the right conditions, but not necessarily to stay.
So I have one more question for you.
Okay.
So 2 recent spacecraft arrived on Mars. Are you familiar with those 2?
Yeah, one of them's from India, right?
Can you talk a little bit about your thoughts on those 2 missions?
Yeah, I would like to congratulate India for being the first Asian nation to launch a probe successfully to Mars. And by the way, it was done at a very low cost, and it shows a great amount of technical progress and advancement. So congratulations. We look forward to seeing the data that comes back from that probe. I think Mars is a very fascinating place. It's the next nearest planet to us, but it's still very far away. As I mentioned, 6-month transit times, we're talking about traveling at about 40,000 miles an hour, and still it would take 6 months on average to get there when the planets are lined up. So even our closest planet is quite far away, and getting just an unmanned probe there is quite an accomplishment. I think the batting average is about 50%. Roughly half of the probes that the United States or Russia has tried to send over to Mars haven't made it. So for India to make it on its first try is quite an accomplishment.
All right, Dr. Chiao, thank you
for
joining us.
My pleasure.
And we have several students and teachers and principals across the ocean that we're very, very excited to have you here with us, and we appreciate you.
Well, my pleasure, and good luck to all of you. It was a pleasure talking to you tonight. Look forward to meeting some of you. Hopefully you'll be able to come to symposium like some of the teachers were able to last year or this year, and best of luck to you. Thanks.